gang here. But I would love it if we could just do a really quick round of introductions one more time. Just your name and the organization or church group you represent, or city department if applicable in this case. So I just want to let you all know that we are going to be recording this meeting because I've gotten a couple requests from others who can't join us today to do so. So I hope you all don't mind. Be on your best behavior and do your hair perfectly. Okay, so I'll start the introductions. My name is Lydia Braden, and I'm with the Cordova Community Council.
I'm Dr. Dan with River City Christian.
I'm Jen Larrett with the Church of Jesus Christ of Latter-day Saints.
Walter Little with St. John Vianney and the Food Locker.
Shelley Blanchard with Community Council.
I'm Elizabeth Brick from the Rancho Cordova United Methodist Church.
I'm Lori Ann Olm from the City of Rancho Cordova.
Kelly Baker, River City Christian.
I'm Jeff Bassett. I'm the pastor at Cordova Church of the Nazarene.
Who's left?
Do we miss anyone?
I'm the city councilman and mayor, and your speaker today.
I think we missed, Megan, did you get a chance to introduce yourself? Okay, I don't know how I missed you. Good. And then I see a Jose on. Is that, can you hear us okay, Jose?
Yes, can you hear me?
Yes.
Yeah, Jose from Rancho Cordova Police Department and Police Activities League.
Wonderful. Thank you for joining us today. Okay, well, without further ado, I'm going to hand it over to Mayor David Sander to talk to us about what's going on in the current pandemic situation.
All right, I am going to do screen share here. Hopefully this works well. How's that? Everybody got a huge virus image on your screen there? We're good? Okay. It's going to be a little hard to stop for questions in the middle of this, although normally that's really how I would like to do this talk. So, Lydia, I don't know if you can set your screen so you can see everybody's pictures reasonably well. I would suggest you just wave a hand. If you have a question, Lydia will interrupt me because the way my screen's set up, I probably won't be able to see enough people over there in this little box on the right. All right, so I'm David Sander. I'm the mayor of the city of Rancho Cordova, but I also happen to be a virologist. A virologist is a scientist who studies viruses. So I I did undergraduate work at a Jesuit university in physics and biology and chemistry, and went to Tulane University in New Orleans, the medical school there, and received a PhD in cell and molecular biology, but my research was in viruses. And people have been asking me, how many virologists are there in the world? And, I don't know an exact answer to that. It's kind of hard to count because there's some people who sort of work in the field but do something else as well. Science can be a little blurry sometimes, depending on how you do your work. But it's probably on the order of thousands of us, which, in terms of the world population, or even the scientists in the world, is pretty small. And my entire adult life, I've had to explain what a virologist is, except for the past 6 months. Now everybody seems to know. So I'm a virologist. I'm probably the only virologist mayor in the country. So my goal today is to tell you about coronavirus, try to answer some of your questions. I'm going to give you an overview with some kind of in-depth little dives into it. And at the end, hopefully we have enough time for questions and to answer those things that may be bothering you. Let's see here. There we go. So we have known about coronaviruses for quite a long time. They were first discovered in the 1960s, and all of us have probably had a coronavirus because the common cold, as we know it, is a coronavirus. So there are 4 listed here, and this is what science does. We label things and we categorize things. So there are 4 common human coronaviruses listed up there, like 229E, NL63, etc. These are viruses you get. You may get more than once in your life. They can cause grave injury if you are in an immunocompromised condition or very, extremely aged and your immune system is not as up to the fight against the virus as it might have been. But otherwise, these are just common cold viruses we all know. However, in the past few years, we've seen some other coronaviruses, and those are listed down below. So MERS, it's called Middle East Respiratory Syndrome. Actually came through a camel, believe it or not, on its way to humans from bats. That virus is somewhat deadly, has not infected all that many people, but it has a death rate of perhaps 30% for those who catch it. SARS was a few years before that, originated in China, spread in the Far East, was largely contained there. It had a death rate of about 10%. And now, of course, we've got SARS-CoV-2, the coronavirus this year, the novel coronavirus 2019 this year. SARS-CoV-2 is very similar to SARS-CoV, which is why it got just the added name, although the disease is different and the death rate is different. So we can talk about that as we go on here. So, anatomy of the enemy. What is this thing anyway? This is a nice little graphic that shows you what the virus looks like. Now, this is a cartoon, obviously, not an actual picture. Can you see my mouse, by the way, if I move it? Is my mouse shared? Yes? Okay. So these are the parts of a virus. We're zoomed way in here to see what a virus looks like. And I'm going to show you a real picture of the virus, or a couple of them in a little bit. This outside area is called the envelope. And this is an enveloped virus, which means that the virus itself, which is made up of all these proteins, and basically every colored thing you see here is a protein of some kind that the virus has made or a cell has made to incorporate into this virus. And then there's this layer, it's a membrane. It's basically a fatty membrane that the virus uses to hold itself together. So it's got all these proteins stuck in this membrane. It's like, you can think of it like a little drop of water, all these proteins on the outsides of the drop of water. And then on the inside, this loop-de-loop thing, that's the genome of the virus. Those are the genetic instructions that it wants to carry to another cell so that it can replicate itself using that cell's machinery. So when we think about the virus and how it works, these outer proteins that are called spike proteins, these big ones on the outside here, and this is also what gives this virus its name, coronavirus, because as you see in the picture in a second, they look like a crown around the virus. These are the proteins that attach to a human cell and allow this virus to infect and copy itself. So these proteins on the outside are also what we try to train our immune system to fight with a vaccine. You take these proteins and you try to generate an immune response against those, because that's the only part of the virus your human immune system can see, is whatever's sticking out on the outside. All right, so these are going to be some electron micrographs of SARS-CoV and what it actually looks like. So here's an image, and you can see this is a single virus. There's actually 4 complete viruses in this image right here. You can see the 4 of them there, and you can see those are those spike proteins that were just in those cartoons. You can see them sort of wrapping around each of these coronaviruses, and this is why they're named corona. It looks like they have a crown, these proteins around them. All right, here's another cartoon, and this one is about showing you how the virus actually replicates itself, how that works. So here's that little cartoon again, a slightly different version, shows that's what the coronavirus looks like. It comes along, it's in your airway mainly, and this is sort of like an epithelial cell in your lung or your throat or your sinuses. Virus is out there, and it finds a particular protein on the outside of our cells. Some of our cells make this protein. It's called an ACE2 receptor, and that virus will lob onto that thing. It attaches to it. And when that happens, it will pull itself, basically, with that attachment happen. That's a normal functional receptor that our cells have. It's normal for us to have it. The virus is just taking advantage of that being there. It attaches itself, and it pulls itself into the cell. And when it does that, its main goal is to get its genome into the cell. So this is your normal, healthy human cell, at least until now. It now has this virus instruction set floating around inside of it. And the normal cell machinery in these human cells is going to look at that instruction and think, oh, that's just another thing I'm supposed to do, like any other cellular process. And so it's going to start following the instructions in that viral genome. And the instructions are going to say, make more proteins that make up this virus. So it'll come in here, the cellular machinery will take over, it'll start making the proteins. The proteins will be processed the way a normal cell protein would be processed. And that process, by the way, is called translation. That happens, and one of the things that is made per the instructions of the virus is another protein that will make yet more copies of the genome of the virus. So one virus gets in, and then it starts making hundreds, thousands, maybe millions of copies of itself inside of the cell, because the virus is taking over the normal machinery of the cell. And as those viruses are made, they make more genomes, they make more proteins, they get processed through the normal cell system. They eventually form new viruses in the cell that get shoved out and released. The virions are released, and then those viruses, those virion, can go on and infect other cells. So basically, within the inside of the cell, this is the process that happens. Now, there are a couple places here where you've heard about things that drugs or therapies that can be used to fight this viral replication, and they're actually indicated here. Ritonavir is perhaps the best early phase drug that we have right now to fight coronavirus infection. It was actually designed for Ebola, which is a similar RNA type virus, different family, but it has an RNA genome like this virus. And so that drug will stop some of this translation from happening. It basically latches on and just stops it. It causes an error in the process. So there's one drug therapy. Chloroquine or hydroxychloroquine, which you've heard a lot about and got horribly politicized, particularly in Europe. It's still used, and it inhibits the virus actually coming into the cell. It probably it's not enormously effective. It has a minor effect, but it's probably the only drug we have right now that has that effect at all. And then there's remdesivir, which is yet another drug. It messes up the processing of those proteins before they can be turned into a new virus. And so these are sort of three drugs that can be used. I have to say, ritonavir over here is the most effective right now. That one's in sort of wide scale use. These other two are narrower uses, not as many studies supporting them, probably not as effective as this. And we are working on hundreds of other therapies, literally, that could potentially mess up something in this viral replication. So now I'm going to move on. Here's another image. This is showing some cells that are literally packed with virus because the cell has been taken over. Look at the cell on the right. All of these little circles, those are all coronaviruses. They've just taken over the cell. The cell has just been turned into a virus factory. And that's what happens. And that's the basic replication strategy for the virus. Let's talk a little bit about the disease it causes. So here's a great graphic. I hope you can see it. I hope the resolution is good enough. But the question is, so, you catch COVID-19 and it starts replicating in you. How does that cause a disease? Well, you have to understand a little bit about the anatomy of the human lung to see where the disease actually happens. Here at the top, you see sort of a normal alveoli or alveolus in the lung, and it's basically a little air sac. The air gets channeled in through the trachea and the bronchioles and ends up in these alveoli, and that's where oxygen and carbon dioxide are exchanged. So this is a normal, healthy one. Blood flows right around there to facilitate the exchange of oxygen and carbon dioxide. When the virus comes in and starts infecting these cells, the cells start malfunctioning a little bit. And the immune system detects that something is not right here. And so inflammation begins to occur. When inflammation occurs, other immune cells want to come in, like macrophages, which are shown right here, and want to come in here and clean that mess up because they know something is not right. These cells are not acting right because they've been infected with the virus and they can see the malfunction. Well, when that inflammation happens, fluid starts to build up in the alveoli. And when that fluid is there, the oxygen and the carbon dioxide can't be exchanged as efficiently because there's literally fluid blocking some of the surface that they rely on. And you can't do the oxygen and carbon dioxide exchange properly if there's a bunch of fluid in there. And so over time, the gas exchange function is impaired, and it's harder and harder to breathe. It's harder and harder to get enough oxygen until finally, you know, some of these alveoli are going to be completely filled with basically the immune response and the process of disease that has gone on. And so that is the problem. This is basically what leads to the majority of the death from COVID-19. Now, there's a lot of other things this virus does, but this is the prime factor. So let's talk a little bit about how this pandemic broke and how it looked. Now, I've got something I have not done in one of these talks before. I hope it works. This is going to be a movie that shows the spread of the virus around the world, and it's really pretty fascinating to watch. Oh, it's working, I think. Yes, so you're going to see, where does it first originate? We will see cases prop up here in China. The virus has originated. The date down here is February 12th at this point. Oh, it got more in China. We see it in France, in Italy, in Iran, spreading. Look how rapidly it spreads around the world. Italy goes very dark. Spain goes very dark. France goes dark. The United States is still not the worst, but we're catching up. There we go. Canada, very similar to us. Western Europe. And on we go. Now we're in June. Now, some of these numbers I have to say around the world are probably not completely accurate, so the map is not 100% true to reality, but it gives you a great impression of how that virus spread from China to the rest of the world in that little movie. And this is sort of where we are, I think, as of yesterday, in terms of how many deaths per million people. And I think that's probably the best measure we have. You have to look at it in ratio to your overall population, not just a number. The number doesn't tell you much by itself. It has to be in relative to something. So this graph can show you how many people have died per million in different places around the world. We know some of these numbers are not completely accurate. China has not been sharing all of their data. It's pretty obvious that they're basically hiding some of the deaths that are occurring in China. Same thing for Russia, same thing for Iran. A lot of the third world countries don't have enough normal public health apparatus to be able to do a report of how many casualties there actually have been. So you sort of take that with a little grain of salt. In other places, the numbers are probably pretty good and pretty accurate. Here's this is an interesting graph. This is basically the same thing we just looked at, except zoomed in. So this is, once again, deaths per million people. And this is as of yesterday, I guess. And you can see the great variation between nations just in Europe. I chose Europe because of the differences here. Clearly, the most impacted nations are Italy, France, Spain, the UK, Sweden. And there is a variation, though, in that Germany is less impacted, Iceland, even less impacted, perhaps benefiting from an island status and a low population. And then as we get into Eastern Europe, I think the numbers are probably lessening in their reliability. But it's interesting to see, just nation to nation, how variant the spread is and the number of deaths. So now we're going to look at the number of confirmed COVID deaths per million people. And this is a great graph because it actually looks like fireworks. For anybody who's a fireworks fan, you're going to see China will pop up first as like the first little firework launch. And what we're looking at is how many people have died per million people in their country over time. So it's like a movie of how this thing has spread. It's similar to the other one, except now you're getting a more numerical representation of it. So there goes China. First out of the gate with their cases, they just surpassed 1 death per million persons, and they level off. There goes Italy, Iran, South Korea, Spain, Belgium, France, Switzerland. Italy in the lead. I will switch over here in a little bit, and you'll see North American nations highlighted, and I think then you'll see European nations highlighted. As they level off, they basically have the spread of the virus under control, or at least it's not spreading as rapidly as it was before. So there's the United States near the top, but being surpassed by Mexico and Peru. And we rank somewhere there below France, around Ireland in the final analysis. So if you listen to all of our media, you probably think we're the worst in the world. Actually, we're not. There's a few worse than us. But given the, you know, the quality of the data all over the place, it's an interesting representation.
I got to reset this. It's just.
All right, testing. Boy, have we done a lot of testing. Everyone's done a lot of testing, but it seems like there's never enough testing. And unfortunately, this also turned into something a little bit political. These are tests per 1,000 people. United States is the top line here. We do just about the most tests, I would say, of any country in the world per 1,000 people. Close to us is France, Lithuania, Canada. I think Iceland is actually higher than us. They're not on this particular chart, but they, once again, have a very small population. And the testing you've seen has increased all over the world. Testing is probably relied upon too much as some sort of a panacea, but there are really necessary times for testing. And we have not, I think, equally deployed those around the country. You've heard a lot about the deaths by state, and I just want to give you a little example right here. This graph is showing you total deaths, like how many, total cases. How many total cases have there been? And you can see, wow, California and Texas and Florida, so many cases. We also happen to be high population states, so that's probably not the best measure. The next slide actually shows you a ratio in cases per 100,000. So now it's how many cases of COVID had you had per 100,000 people. Now suddenly California doesn't look so bad, but boy, Arizona and the rest of the South are not so great. But even New York doesn't look as bad as some of the overall COVID positive rates in the South and in Arizona. This is as of yesterday, 176,000 deaths estimated by the CDC, about 1,744 cases per 100,000 people. Now that's total since the beginning of the pandemic. That's not current. We saw a lot about the explosive capacity of this virus and how fast it can take off. And this is a cool comparison of how it started in New York versus how it started in California. And you can see, look at New York, just shot up, tons of cases, just exploding with cases. Whereas California, where we put measures in place a little sooner, many fewer cases. This is total number, just comparing New York and California. So really, I mean, we're a much larger state. We should even surpass New York if things were even close, but they were far ahead of us. And it's probably because they did not shut down their bars, they did not shut down their transit until days or even up to a week after we took similar measures. So that undoubtedly led to more cases in New York per 1,000 than we had in California. This is a look at California cases during the entire pandemic. You can see in the spring when we were all very concerned about it and it started, a lot of measures were put in place. We didn't have that many overall cases. And as we went into June and July and we released those control measures, we ended up with a lot more cases. Now we also did more testing. So some people would say, oh, you're just detecting more of the asymptomatics, the people who have the disease but don't show symptoms. But if you look at the death chart, it actually parallels the total number of positive cases pretty well. And you can see the background levels here. Don't think that we die in that pattern. We report things in that pattern. Those are weekends, those dips back there in the background. This rolling average here in front is probably the better line to look at. But you can see that the number of deaths in some way sort of parallels this. You can see the effect of testing and that it's not exactly the same. We're doing more testing, we're detecting more. But there definitely has been a big uptick in the number of deaths from COVID since the middle of June. If you look at just California, by county. Get an interesting graphic here. The size of the circle indicates roughly, how many cases they've had. You can see that, the far north in California, very few cases. The mountains, very few cases. Just north of us, not so many cases. But if you get to Southern California, enormous numbers. And Bay Area, a little bit east of the Bay Area, some significant number of cases. So there we are in this particular chart. But look at the dominance of Los Angeles County in the overall numbers. 233,000 cases out of the total. And Sacramento's not even in the top 7.
We have a question from Mr. Walt Little in the chat. He asked, proper wait between exposure and testing?
It takes at least 2 days and up till 14 to show symptoms and get a positive result. 14 is probably too extreme. That's sort of an outlier. In general, people are showing symptoms or would show up positive within 2 to 4 days. So 2 to 4 days is probably the appropriate window, but you probably want to wait at least 2. Before that, you're basically not giving the virus enough time to replicate. So this is off the Sacramento County dashboard that shows just our cases by county. So I showed you the world, the United States, the state. Now we're down to our county. Again, in the spring, not so much going on here. There's our so-called wave of the spring right there, March through April. Very, very few cases. And things changed. You can see generally things are dropping. Again, we have fewer number of new cases coming in as we proceed on. There's some other interesting data they present. They show cases by age group. So how many kids from 0 to 9 have tested positive? 611 versus 20-year-olds, 3,670. And these are deciles of age. So if this thing spread normally between all age groups, you would see basically a straight line here. Everyone would be about the same, but clearly it doesn't. It infects different ages at different rates. And it is probably exceeding the norm here in the younger folks, those under 40, because they're most likely to go out, socialize with each other, mix, and spread virus between themselves. I certainly know that's true for my nephew, who is in that age group. His social media posts are filled with all of these big group parties of unmasked people behaving as if there was no virus in our community. And you can see among the extremely aged here, not that many cases, given how many people are probably alive in that decile, but is particularly dangerous for those folks. There is also some difference by ethnicity. There's an outsized representation in the numbers of Hispanic folks and African Americans. Asians are just about on target for their share of the overall population. Whites are a little below our share of the population in the overall representation. If you look at how sick have we been as a result of this, here's a great chart. It shows how many people have been hospitalized all the way from the beginning through the drop and to now, and how many of those ended up in the ICU, a second number. And down here at the bottom, how many people are in the emergency room. Very interesting data. I'm going to zoom in. Whoops, I think I've got another graph coming up later that shows how many cases we actually have within the county and how they're distributed. But what comes up, and I just mentioned it in that previous slide, masks and gloves. We see people wearing masks most of the time now. There was a lot of reluctance to do it at first. There was some mixed information at first from the CDC and from others as to whether masks made sense. And largely that was because before this virus, studies that had been done of masks and infectious disease suggested that if you gave the general public a mask, they tended to react in a way that made them feel they were immune to something. Like, this mask is going to protect me from everything. I don't need to take any other precautions. I can do anything as long as I have this mask on. And the reality of the mask is it's not protecting you, it's protecting everyone else from you. Because the mask doesn't really filter that much air going into you. It filters a lot of air going out of you. Specifically, it's getting rid of the droplets coming out of you as you talk or breathe. And so the mask is there to protect everybody else. It's not so much a defense measure for you. Now, I should say the N95 mask is the reverse of that. It does both. It protects everyone else and it protects you, but you should not be wearing those long term unless you have a specific health condition that sort of requires that you take that extra security. So what should you do in public? Should you wear a mask? Yes. And what really changed the studies pre-COVID versus post-COVID was this idea that there's a lot of people walking around with this virus who don't know they have it. It's in them, it's replicating, they're sharing it, they're spreading it, not as to great a degree as someone who is ill with it, physically ill and has a lot of symptoms. But these so-called asymptomatics, as they don't have a lot of symptoms of the disease, are among us spreading the virus. They don't know it, we don't know it. There's no way to tell. The only way to inhibit them from spreading it is if everyone wears a mask. So if you're wearing a mask and you're infected and 2 days later you come down with symptoms and you know you have it, those 2 days beforehand when you could have been spreading it, you would not have been, or at least not as much, if you had a mask on. If you get this disease or you never even knew you had it, but were wearing a mask while you had it, you're not as likely to have spread it. That's the new rationale for wearing the mask. And we frankly have not had an infectious disease that behaves that way before with this large number of asymptomatic people out there. That's what the change was. And that's what led to the initial no, masks don't make sense because they're going to make you feel too brave, to everyone should wear a mask. It's a question of how many people are walking around spreading it and don't even know it. Gloves, on the other hand, are still generally a no because they cause that behavior. And I'm sure all of us have probably seen this. I'm not sure I'm seeing as much of it now as I saw 2 months ago. But crazy things like, you know, people eating their lunch somewhere in public and they're wearing their gloves that they just, you know, walked through the grocery store with, or touched all the door handles with, or wiped their face with, or, I mean, it's just ridiculous. It causes ridiculous behavior. So you put the gloves on, you think, oh, I'm totally safe. And then, you know, everything gets on the glove and then you're touched. Doesn't make any sense. Causes bad behavior. Wash your hands is the easy answer. Wash your hands. Use hand sanitizer. Don't wear gloves.
What about the best mask? Mr. Walt asked if there was a best mask.
You know, the recommendation is for a double layer cotton mask. So like the sort of fabric someone would use to quilt, or t-shirt fabric, something that's made with sort of a double layer of that is pretty effective in stopping most droplets from leaving your mouth. The things that you pull up with, I think they're called gaiters, have actually been shown to make it worse. So you don't want to do that. You want some sort of a somewhat form-fitting mask over your face. If you can get the medical style mask, sometimes called the surgical mask, and I have one sitting here, but they're often blue in color with the strings. Those are particularly effective if the heavier masks, the double layer cotton fabric ones, don't work for you. I know for me, a lot of the cotton masks cause so much humidity around particularly my beard. It's uncomfortable to wear, but the surgical mask does not. So that's a good option. Might work for you, Walt, in that sense. So how to actually wear it properly. Always wash your hands. That's the big recommendation. Wash your hands. Make sure it covers your nose and your mouth. I'm not sure what everyone thinks they're doing, wearing it below their nose. It's a little bit of silly behavior. It might actually be, again, counterproductive. If you can imagine exhaling virus through your nose that sticks on the mask, if you also talk or exhale off your mouth, you could just sort of project that off the front of the mask. Doesn't make a lot of sense to do that. I know it can steam up your glasses. I certainly have that problem. Wear a mask, the glasses get steamed up. If you put it below your nose, you don't have that problem. What you really need is just one with a little piece of metal in it, like a twisty on the top that'll sort of fit the form of your nose and block that steam from steaming up your glasses. You try to keep it against the sides of your face here, although most of the air when you exhale is going to be exiting behind the mask in that direction. And you try to make sure that you can breathe easily with it. There are some people who have respiratory issues, and wearing a mask is going to either psychologically or physically be too much of a restriction. They're going to have to modify it in some way or not wear it. But other than that, if you just follow these simple rules, it's not that hard to wear a face covering properly. And of course, as I said before, we're not wearing this for ourselves, we're wearing this for everybody else. So if you keep it on when you're in public, try not to touch it too much. It'll be a productive thing for all of us. There are actually mathematical models that are showing if everyone just wore a mask, you could just about eliminate the spread of the virus. It's just enough of a difference to inhibit the spread that you might eliminate it if everyone wore a mask all the time. Now, the likelihood of that, of course, is next to zero. But were that to be possible, you can really, really decrease the spread of the virus. So I talked a little bit about testing before, and I wanted to make this point about two different types of testing. There's molecular testing and there's serological testing. Molecular testing is testing to see, is the virus there? Is there virus in your nose or in your sinuses? Serological testing is a retrospective one. It's saying, have you been exposed to the virus? Has your body made antibodies to that virus? So serological testing is done using a sample of your blood. Molecular testing is done using a swab that as some people said, they test your brain because the swab is inserted very deep into your nose. These are the two examples right here. In molecular testing, they're looking for, this is the PCR thing you've probably heard about. They do the nasal swab. They detect whether or not those genetic instructions are present in you. And if so, they determine, yes, you have the virus. The problem is, or the good news is, this is really highly sensitive. You can process it pretty quick in a number of hours if it's done properly. And you can detect someone who's been exposed just, a day or two ago. The downside is that the test is finicky. It can't be done out in the field. It has to be done in a proper laboratory. It doesn't tell you if the virus is still live. So in some cases, people who've had the virus and have killed it off still have parts of it laying around their sinuses. This will detect the parts and it can't determine whether it's part of a functional virus or a non-functional virus. So that's sort of the cons of this type. A lot of the news stories you see where people are talking about, oh, I've been reinfected, is detection of virus that is no longer functional by PCR. Now, can people get reinfected? Probably. We really haven't had this virus around long enough to know, but it's probably possible, although the disease is probably diminished. Now, the serological testing is a blood test. It takes a few days for your antibodies to be produced. So after about 2 weeks, this says 9 to 11 days, but I would say after 2 weeks, you would certainly be able to tell, have I had COVID or have I not? This is a pretty rapid test. It's pretty cheap. You can do a lot of them. It's pretty reliable. The difficulty is it can't tell you if you still have infectious virus, and it could potentially get a false negative depending on the quality of the test. And there are so many different serological tests out there right now that it's a little uncertain, unless you're with one of the very large test companies, whether you're getting a really, really accurate and solid serological test. So molecular testing, saying, is the virus around? Serological testing, have you been exposed to it? Two different types. A test is not a test, it's not a test. So much focus on fatality rates of COVID-19. This is one of the questions I'm probably asked more than any other question. How deadly is this thing? And I think people are just trying to rate it. How worried should I be? How scary is this? Well, when it first popped up and the WHO was looking at it in China, they thought it might be 5 to 10%, like the SARS virus that had preceded it. Over time, with treatment, they were figuring out a little bit about how to better treat this disease in China. It dropped to maybe 3.4% was the estimate the WHO gave. In New York, when the virus first showed up, the death rate was probably 5%. It may have been as high as 10% among some of the early patients. But over time, infectious disease experts and the physicians who treat this disease have figured out a lot of different therapeutic changes that can be made to maximize the survival of patients. For example, early on, we were putting people on respirators. Anytime they had a breathing difficulty that caused their pulse oxygen to drop below about 92%, we were putting them on a respirator. And as it turns out, in retrospect, that is one of the worst things you can do for a COVID patient. You want them off the respirator as long as possible. It's not 100% clear as to why that's the case, other than just physician experience and looking at large number of patients and how they were treated. Patients that were kept off the respirator the longest did the best. And so now you will see physicians doing a lot of things trying to keep people off of respirators. China early on was experimenting with steroids in patients, trying to knock down the immune response so those parts of the lung don't get filled up with as much fluid. And it was disastrous when they tried it. Turns out, if you adjust the timing of it just right, there is a window of opportunity during the disease of COVID where you can really knock that disease down and decrease the damage being done to the lungs if you use steroids at the right time. But it took thousands of patient lives, in essence, to figure that out. This is how medicine and science works. It's iterative. You do something, you try something, you observe, you do something better. Try to figure out why you're seeing the pattern you're seeing. Improve and improve. So now, with those improvements, the CDC is saying, you know, that fatality rate is probably somewhere between 0.26% and 1.4%. And a lot of infectious disease doctors are talking about this fatality rate will probably settle to about 0.1%, maybe 0.2%, somewhere in that range. And what's interesting about that is that's the same death rate as influenza. The seasonal flu that comes through our country every year and goes around the world every year, its death rate is 0.1%. COVID might end up there when we finally figure out how to best treat it. Influenza, we know how to treat. We have drugs, we can track that disease. COVID, we're still figuring some things out, but as we figure out yet more things, odds are it might be just about as deadly as influenza. Right now, it's maybe twice or 4 times as deadly as influenza. All right, I have not been able to cover everything I wanted to cover in this talk, but I've covered a few things here, and I've left some potential questions here at the end. And I'm open for any other questions you guys may have. Let me change the screen sharing.
I guess. Elizabeth has a question. Go ahead, Elizabeth.
I do. There's a lot of talk about, you know, who are in the high risk groups, and obviously people with immunodeficiencies, et cetera. Has there been a sense of which immune deficiency kinds of disorders are the most prevalent in, you know, risk? And then is the risk of contracting the virus or having a worse course of the virus or of mortality? I mean, I'm just kind of curious about those kinds of risk factors because we see these lists of people on the news or, you know, of syndromes or whatever. And also related to that is if people are taking immune suppressing drugs, and there are tons out there like Humira and those kinds of drugs, does that also increase risk?
Yes and yes to the 2 questions. We may not have enough data to really go syndrome by syndrome and say, you know, who's more at risk here or there, in part because some of those things are a little confounding. People will have multiple conditions, multiple outside influences. They may have diabetes and an immune condition, or obesity and an immune condition, or, you know what I mean? There's a variety of things going on there. In addition, everyone's immune system is a little unique. So if I catch this virus and my body makes an antibody against it and fights it, and your body catches this virus and makes an antibody against it and fights it, there's almost zero chance that our antibodies are doing the same thing. We've each chosen, our bodies will choose something in that virus to attack. And mine might be highly effective, yours might be marginally effective. It got us both through, but in reality, we had very different responses to it. So there's just enough gray in there that I can't sort of specifically answer the first question, other than to say anything that is suppressing your immune response is leaving you more open to the disease. And I guess I would qualify that by saying it's going to make you more likely to, not likely to catch it. That's pretty much going to be the same all over the place. But it's that next phase of how many cells does this virus infect? How much of a systemic disease do you get? That's where the variability will come in. Everyone will sort of catch it and then start to fight it. But how that fight goes on and the side effects of the fight are the variable. I don't know if I helped you out very much with that. But.
Yeah, you did. And I'm asking as a person who has Crohn's disease and takes a biologic and,
Yeah.
obviously feel like there's a lot of risk, but I didn't know if it was a greater risk of actually contracting the disease or having a harder way through it. So now everybody knows my health history. Sorry about that.
Well,
Hi,
look,
everybody.
in that specific case with Humira,
It's a Stellara, but yeah.
oh, Estelara?
Similar. Yeah, that's what I'm taking.
So, in that particular case, you're not getting broad spectrum immune suppression. So there are multiple avenues of the immune system. There's a humoral response, there's a cellular response, there's a basic response. Other parts of your response are still intact. So it's not like everything's been knocked down. In your case, you're just decreasing one bit of capacity. And you're otherwise, if you're otherwise healthy and don't have other compounding conditions, then still it's a risk, but this is not the most dangerous virus in the world in that sense.
Hey, David.
Thank you.
Dan DeShong here. I really appreciate your presentation. I have a question about all of the death rates. Are we ever going to get to the point to where we discover all the comorbidity factors and wind up with any kind of data that said people died from versus with?
Yeah. Yeah, that is messy. It's messy because of how our system works. So my wife's a physician. If she ever has to sign a death certificate, she gets to decide what goes on those lines. It's basically a primary cause and then other factors is how you write it. And in some states, physicians have been required to fill in the first line, regardless of what killed the individual, if there's a positive COVID test, to put COVID on the top line. Because the state's trying to figure out how many COVID cases are resulting in a death. So literally, there have been cases of someone dies in a car accident, but on autopsy, they were positive for COVID, top line death, cause of death, COVID. Secondary cause, car accident. So it makes no sense. And that is definitely influencing some of our practitioners. And in other cases, they may not be listing it when it happened. I know in New York City, for example, there were ambulances going to a lot of homes, finding people basically who had already passed away. They'd been called because someone stopped breathing and family thought it was, a heart attack or something. It was probably a stroke or a heart attack due to the virus, because they ended up being, when they did autopsy, quite sick from COVID. They just didn't realize it or know it or didn't do anything about it. So there are probably other deaths going on that aren't being labeled COVID that should be. And where that all ends up in the end, I don't know. Public health is a complicated, messy business. And we'll probably never have absolute numbers on that. It's always going to be an approximation and a best guess. The good news is, if you have enough of those best guess and enough approximations, you can get to some pretty good answers. But if you look at the detail of it, there's going to be messiness.
All right, thank you.
Would you be okay if we shared this whole presentation, this video, onto like the VOAD website? Because we have a lot of churches from other areas and things like that that are going to that website and I think this data for them would be really helpful.
I think so, yeah. I shortened this one a little bit over one I gave previously in the year, but I think if you'd like to share this, that'd be all right, if you think it'd be helpful.
Yeah, I think, like I said, I think for us, this is almost like I know now we're kind of have more data and things like that, but I think just kind of understanding it and, why we're doing some of the things is kind of more encouraging for people to wear their mask properly. So.
Is there any chance you could leave out the Q&A or just delete my question?
I could. Oh yeah, absolutely. Look, that's appropriate.
Thanks.
I have a question about the treatment options. We've been hearing a lot of information about, accelerating testing for treatments and drugs and how that is rapidly becoming political as well. And I'm wondering about this convalescent plasma that they've been talking about as an option. What can you tell us about that?
Convalescent plasma? That is the reason immunology and infectious disease was sort of invented as a specialty, was this whole idea of can we take plasma from someone who recovered from this disease and give it to someone who has it? In the 1800s, they were trying that. Even before they understood blood types, they were trying that. So it's a really good potential therapy. Frankly, in the United States, we have not used it as often as they have in other countries, in part because of our medical sophistication. We often have better or more reliable or more portable, whatever the case may be, therapies. But in this particular case, it is reasonable to assume that it can be effective. And there are great trials going on right now to demonstrate that. And the results I've seen in early stages are quite positive. The challenge will be getting enough of the right type of antibody to use as a therapy on a routine basis. So traditionally, the challenge here is you don't get enough donors, or the difficulty in separating out the antibodies you want versus everything else degrades the effectiveness of it. There are challenges like that in the process. But assuming you get enough donors on the front side and the process is nicely optimized, it can be pretty effective.
Question, David?
Yes.
Curious about this rush to answer. I mean, there have been cases in the past where medications were given and the long-term results were way beyond disastrous.
Mm-hmm.
And I'm curious, what is the speculation about the side effects, if any, of the particular drugs that they are putting on the fast track?
Yeah, that's always the challenge. To get a new drug to market in the United States costs just about $1 billion, maybe $2 billion in the different levels of studies. It typically takes years of effort. It's a very rigorous process. It involves testing thousands of people in the end before the FDA would approve a drug for the mass market. But the difficulty is, even with thousands of patients and billions of dollars, you're still not going to determine all of the potential side effects until you release it for open use. And so it's always, and this is true of any product actually, you know, paint, if you're selling paint, someone's going to put it on something you didn't test it on, and oh, surprise, look at that. Didn't expect that to happen. Same thing with medications, and in particular because our physiologies and our conditions and the varieties of people that are out there with different conditions and small deviations are going to just result in odd things happening. So it's impossible to test for all those up front. I would say in this particular case, we have so much energy being poured into this and so many different things being tested. What's likely to float to the top would be better than what you would see in a normal drug discovery process. Just because there's so many more candidates being tried, the things that come up on top are going to be better than we would have gotten otherwise. So I have a little more confidence, frankly, in the drugs that might be produced in this rush period, as opposed to what would normally be produced in a slower process, if that makes sense. Because literally we're trying hundreds of things are being tested. Normally for someone, you're going to go out and make a vaccine, you might test a few, half a dozen or a dozen candidates might make it to the test. We've got 172 just vaccines out there being tested in people. It's a remarkable, nothing like this has ever happened before.
I have a question, and I had to step away, David, so if you answered this as I was away, please say, I already said that. But in the interesting, I heard David give this talk early on at the Rotary Club, early on, and as a few months have passed, some more information is now available. And one of the things that struck me was when we were talking earlier, a few months back, we were looking at Sweden and how they were taking a very different approach, whereas they were just going for the herd immunity by just sort of live and let live. And now I see that months later, we're exactly in the same place Sweden is, despite all the interventions. So what can we draw from that? Had we not done anything, would we all just be in the same place?
That's a very interesting question. And of course, it's been unfortunately politicized by our media again, but thankfully not really by the scientists who have looked at it. A little bit by the scientists. There's some like national rivalry sort of politics that go on in the scientific community there. But what's interesting about it is in Sweden, they did not place the restrictions we did. You know, bars and restaurants stayed open, but they told people to be smart, to socially distance. They could wear a mask if you wanted to. They did a few things. And as it turned out, when the Swedish government told their citizens to do those few things, the citizens did it. That's what's interesting about it. So people who were specifically, they told people who were at greater risk, please don't go out in public as much. Please find ways to be safe and segregate yourselves. And those folks did. And the rest of society helped. For some reason, when you tell Americans, you know, hey, we need to go do something, immediately you got 40% saying you're crazy, I'm not even going to consider that. You know, another 20% are saying, why isn't everyone else doing that? You ought to be in jail if you're not doing what they say. There's enormous divisiveness that doesn't appear to have been as present in Sweden. So that probably benefited their strategy. Because if you have a more disciplined population willing to follow those instructions, the other things that are probably present there is they probably don't have quite as much mixing as we do. Their cities seem to show a pattern similar to ours in terms of spread, but their rural areas really did not have much spread at all. And those are probably the two leading factors, sort of population density distribution, as well as how well did they follow just the generic advice of you know, keep yourselves apart and wear masks, wash your hands a lot, and if you're at risk, segregate yourself. Their herd immunity numbers, I don't know. I mean, our herd immunity number in the United States is probably nationwide on the order of 2 to 4% of us have been exposed to this virus. We need to get to 60 or 70 to actually have herd immunity. So to date, you know, 2 to 4% of us have been exposed to this virus. We got to get to 60 or 70. Sweden is above us, I think, in those numbers, but probably not above 10%.
Plus, I had to stay home and put together all that IKEA furniture.
There are other factors involved, certainly.
Thank you.
I have a quick question, if I could, David. You talked about the best masks and better masks than others, and I was wanting to ask a little bit about mask care. So I've heard a lot of mixed back and forth. I read online. I see people wearing masks and then they take it off, they put it in their pocket, we throw them in our purse, we, you know, throw them around. So how often should people be washing their masks? And then 2, there's a group that has been looking at making lanyards, the kind of lanyards that hold your glasses. They're looking at making those to hold the mask so that it hangs around your neck and then it's easily to put on and off. What do you think about something like that?
If the main purpose of the mask is to keep your droplets from being broadcast, it doesn't matter quite so much whether it's in your pocket, you know, for a while or hanging around your neck for a while. That doesn't really increase droplet spread, you know, when you were to later put it on. If you were infected and didn't realize it, and your droplets then were in that mask and you were handling the mask and then touching other surfaces, that would spread your virus, right, potentially to other people. Because you would touch it on your mask and you'd grab that door handle, you'd touch it, you'd touch the thing in the store. So the general advice is don't touch the mask. If you do touch the mask, don't touch this part of the mask, detach it from your ears. That would be probably the only precaution I would put in there. In terms of washing it, you should probably wash it when it doesn't smell nice, or daily if it can handle that, or something. But I wouldn't go to too many extremes. I've heard about people putting them in the oven and microwaving them and all sorts of things. I think a lot of that is done with the idea that the mask is protecting me from something as opposed to protecting everyone from me. If you think about the outside being dirty because I'm breathing in through it and all the dirty stuff's on the outside of it, that would be true, but that's generally not how they work.
David, could you please explain again the exposure of hard surfaces, the timing? You know, somebody you mentioning a door knob. So is it going to stay there for 5 minutes, 3 days, or you know that kind of question? Because that comes up a lot. Is, oh my God, because we had a situation where somebody was in a building 3 days before anybody else was even in there, and they panicked, and now you got this whole community that's quarantined for 14 days, and it may not have been necessary other than, you know, somebody panicked.
Wow. Yeah, there's been a lot of craziness with that. I know. I did get consulted by some churches actually when we were allowed to reopen in Sacramento County, and one called me and said, you know, we haven't had anyone in our sanctuary since March. And before we go in there, we think the first thing we need to do is a super deep cleaning to remove the virus. And this is, you know, it was months before. There's no virus left after months in your empty sanctuary. But days, that's possible. You know, we don't know exactly the route by which this virus is most likely to spread, although it really appears to be droplet, mainly droplet, maybe 2/3 droplet. A portion of it is probably spread by something called an aerosol, which is an even smaller sort of droplet that even a mask won't really inhibit that much, and will stay floating more and more in the air for a longer period of time in an area. Some of it probably spreads, a little bit probably spreads that way. But some probably spreads through contact and between strangers, you know, both touching the same object. But for that to happen, you have to have someone who's infected. They have to get virus on their hands, which means they've touched their face. It's one of the things you shouldn't do too much. Touch your face, get virus on your hand, touch another object, and leave it there. And then someone else has to come along within a prescribed amount of time, touch that same surface. Now you're not infected because it's on your hand. You only get infected if you know, rub your eye, rub your nose, something like that, after touching something that is contaminated with virus. So it's not the easiest route, that contact route. It's because the other route, breathing in a droplet, that's super easy. You know, you just breathe, you get the droplet in. That's super easy to get virus in. The contact method is a little more difficult. But in general, washing your hands eliminates almost all of that contact risk. If you can keep your hands away from your eyes, nose, and mouth, and as humans, we like to touch our faces. So, but if you can keep that in mind and wash your hands a lot, particularly, you know, if you were in a store and you come back out, use the hand sanitizer in your car. If you were out somewhere in the community and you come back into your house, wash your hands. This is most likely where any spray virus would be, is on your hands. Other objects, it varies so much on the individual conditions. For example, there was a study done, if there's virus left on a surface out in the sun, it lasts between 30 seconds and 7 minutes, or maybe it's 13 minutes. 7 minutes or 7 seconds and 13 minutes, depending on how much sun it gets, because it just can't handle the UV radiation. It fries the genome of the virus. Other surfaces, you know, you could concoct a perfect situation where something is refrigerated and it was a large droplet to start with, and it didn't get dehydrated during that refrigeration, and it was there for 2 weeks. So somewhere between 7 seconds and 2 weeks is the answer for all surfaces. But then there's just so many variables in between. The best advice for example, a church, best advice would be clean the things that people touch. If that's the end of the pews, clean the end of the pews. If that's the doorknob, certainly would be, clean those. Just use a normal household cleaning product, Lysol even, spray, anything like that. Anything with any acid or base or detergent in it will wipe the virus out. It's not at all tough against those things. Even alcohol, just alcohol and an alcohol wipe will destroy it.
You mentioned the UV stuff. There's a lot of objects out there for sale.
Oh
like
my
those
gosh.
UV wands and all that crap. Can you just debunk all of that stuff?
It's pretty
for
much
us?
all junk. It's pretty
okay.
much all junk.
Good.
It's yeah, boy, I've seen people trying to sell acidified water. Like, what in the world is that? Anyone who's had like general chemistry 101, I can show you in the lab behind me why that doesn't work.
Yeah. Okay.
But yeah, I've seen aerosol machines that supposedly like spray aerosol, you know, in the room at night. Oh man, yeah, rotating light bulbs in the room, and it's like, have you ever heard of shadow? or
The Jedi one that's
oh yeah, that's a good one.
ultraviolet.
Get enough UV on all the surfaces would you need like the sun shining on it. 15 minutes. I think that's what you need. It's not easily produced. There are probably some of those that work in certain environments, but I can tell you, based on virologists working in lab with viruses, we've tested a lot of these things. You know, how do we clean up after ourselves when you're working in the lab? And it's not simple. It's not super simple to eliminate all of it. The good news is this thing is not super tough. It doesn't hang around for weeks like, you know, measles might, or other viruses. It doesn't have a hard shell on the outside. It'll dry out, fall apart pretty easily. And if you wash your hands and you clean the most touched surfaces, you're probably eliminating 90+% of the risk from contact. And that again is a minority of the way that people actually get this. So I know people were like bleaching bananas and all from the store, all kinds of stuff.
Sounds delicious. I just got really hungry, so thank you for that. Okay, well, I'm gonna thank you, Mr. Mayor, for sharing that info with us. Thank you guys for sticking around for a little extra time. I do want to get into a couple of the other agenda items we have for today, but thank you again for sharing all of that. I'm blown away by all of the technical pieces of this, and I feel like a much more informed citizen. So thank you.
All right, thank you.